This is probably my favorite system design concept. I just find it super cool that you're able to go ahead and super easily 10x your read speeds, and it's not even that hard to implement or understand. So let's go ahead and start explaining. So the way I like to go ahead and think about it is by putting myself in a situation. Imagine that a company needs to go ahead and find a username, if it's taken or not, in a matter of seconds. Now the problem with this is if you go ahead and you do it the traditional way of scanning every single file, if it has the username already taken, even though you're using a computer, it's going to take way too long. It might take a few seconds, a few minutes, and that's just unacceptable these days. It needs to happen within a second or two. Now imagine a company has thousands of files, and in each and every single file it has thousands of usernames. Now again, we said the naive way of searching every single file is going to take way too long. So you might be thinking, well, what if we go ahead and alphabetically sort it? That still doesn't solve it, because there's going to be still dozens of files with millions of usernames in each one. It's going to be way too long. You need something faster. The answer to that is to have a Bloom filter on top of each and every single file. The Bloom filter will immediately tell you within a fraction of a second if that username is not present at all, or it might be inside the file. All right, great. So now we know on a high level what a Bloom filter does. It can immediately tell us if something is not in the file, and it can tell us within a good amount of accuracy if something is inside the file. Let's look deeper into what a Bloom filter actually is. A Bloom filter is essentially just an array of zeros and ones. You start off with a full array of zeros. The way you go ahead and you find the size of array that you need is by using a formula and plugging in the desired accuracy that you want. So the other moving piece in the puzzle is actually how many hash functions you need, and the way you go ahead and find this number is by actually using another function to calculate the number of hash functions that you need by plugging in the size of the Bloom filter that you have. All right, so to make this example kind of simple, let's say that our formula gave us a array of size 10 and we need 2 hash functions. Let's also pretend that we want to go ahead and make this Bloom filter be able to detect if the username orange is in there. So what we're going to do is we're going to pass our orange username into the first hash function. The first hash function is going to go ahead and tell us what bit in the array we're going to go ahead and flip. So let's say it outputs the number 5. So now the position at 5 is flipped to a 1. Now we take our orange username and we pass it through the second hash function, and this one tells us to flip the position at 7 to a 1. So now you can kind of already tell what this is going to help us with. This is how you flip the bits in the array. You're going to go ahead and do that for every single username that you have in that file. So let's say we passed in 10 other usernames and all these bits got flipped. So now for the next username, when we want to check if banana exists in the file, take the name banana, pass it through the first hash function and the second one, and we check if these bits have been flipped to a 1. If they're both a 1, then that means that within a 99% accuracy, banana is already inside that file. To make sure, we need to go ahead and actually check. If either one of the bits is not flipped or both of them are not flipped and there's zeros, then we know within 100% accuracy that the word banana is not in the file. So now you can already tell how this is going to save us a bunch of time, especially if we have hundreds of files and not just one. Now there's one important property of the Bloom filter that you need to go ahead and keep in mind, and you already saw it throughout this video. It's the fact that the Bloom filter can actually give you false positives. Now it's not the worst thing ever, because having a false positive is just going to waste a bit of time. Let's say you have, out of 1,000 files, 10 files that are a candidate. You have to check 3 out of thousands of files. It's not that bad. But the really good thing is that it is guaranteed that it will never give you a false negative. A false negative is super detrimental in this situation, because imagine the Bloom filter tells you, well, the username is actually not in this file, but it actually was. And now you end up having a duplicate username in your database. So having a bit of false positives is a small trade-off, which is completely acceptable because we're going to save so much time. I use Bloom filters on one of my database projects where I recreate an LSM engine, and I was literally able to go ahead and 10x my read speeds. So it's something that is used throughout the industry. Almost every single database engine is going to use Bloom filters because it's just way too useful to avoid.